Okay, so now that our match move is done, we can start looking at the model builder node and making our set geometry. So in the grand scheme of things, we have ticked off this part of the comp, we've ticked off this part, and now we're going for this part, which is the set geometry. So just like in the other series, which you can refer to for the model builder node, we just need to do the same job over here. So just to remind you, that is creating a model builder, hooking up the source to the undistorted plate. That's the key difference. We're using the undistorted plate now, and our match move camera. And it is a case of building all of this geometry. So starting with the Rubik's Cube in the middle, and I'm kind of on the center frame here. Now what I did there was I undid that point because I don't really want to define where this point is because I can't really see where it is. So what I would prefer to do instead is define these points on the edges where I can see the actual edges and corners. So when it comes to this point, instead of trying to find the actual corner, what I'm doing is looking along the length of these lines to try and get the edges to line up. The same with this point over here, because it's a rounded corner, I don't want to be picking this part. I want to basically get this so that these lines follow the edges, and that might mean that the corner, the true corner of this box, is slightly off. Okay, so without setting any keyframe on that point, I'm going to move through the footage and line this box up a little bit better. And this is all the stuff that is covered more in depth in those other tutorials. So it would just be a case of going through the footage and lining that box up. I would do the same thing with these boxes in the background. This white box, this blue box, this little plastic box over here, and the table itself comes from a card because we set our ground plane on our match move, so we don't have to build geometry for this, we can just use a card. So the result of all of that would be, here's one I prepared earlier, where we've got all of the geometry in the scene built in the model builder, and all of those separate parts go into a scene node, including the floor, with the camera, and they get sent into a write geo node, where we write out as FBX. And just note that I am always versioning everything. If it's an FBX that you're liable to overwrite or not, give it a version. No matter what, give it a version. Always version things. I've even versioned my cameras. So this is match move version 1, which made a camera version 1. This has all come from lens distortion solve version 1. So we want to keep this paper trail of version numbers all the way through our work. So that would be, we would write this out as FBX, and that would be this part of the comp ticked off. Okay, now we're going to look at writing out an image plane to Maya. So this would be this section over here. And this is a pretty simple section to cover. All we're doing is taking our, if we follow our stream, we're taking our plate. We are bringing that plate into our undistortion nodes, and then follow this pipe along and down. We're taking it into a text node and then a write node. So this text node, I find is sometimes helpful to just write down what the certain aspects of the shot are. So one very important thing that I like to denote on the plate itself, on the image plane itself, is the render resolution. This is the resolution that we're going to be rendering at in Maya. And when we come to render things in Nuke, as in using the scanline renderer, we're going to have the same resolution as well. So as far as our CGI is concerned, this is our render resolution. So what I mean by that is, in Maya, in our image size, where you're used to picking something like HD 1080, in here we're going to go custom and type in that custom resolution. So that's where these numbers live. So I sometimes find it handy to literally put these on a text node and put them onto the plate, like so. So that gets baked into the image. Now keep in mind that this image plane is going to be a temporary image plane. We haven't removed the markers. That means when we put CG objects in, they're going to reflect blue markers. That's bad. They're also going to reflect this text. They're also going to reflect this black line, which is actual image data. So this is just going to be a temporary image plane that we make. So keep that in mind. Later on, we're going to disable this text node and get rid of those black lines. So when writing an image plane to Maya, we want to use EXRs because we're working in ACES CG. So we want to take away any confusion from that workflow. So just to go over my settings here, I am rendering out my image plane to my project, Rubik's Cube project, into source images, and then image planes, and then into this file here. So let me just step you through what this means. So we've got image plane version 1, so this is match move version 1, and then UD, which means undistort, version 1. So this is match move version 1, undistort version 1. So that's the paper trail of the two things that we're keeping track of, our camera and our undistort version. We're writing it out as ACES CG, so that's in color spaces, ACES CG. And to save space and to give us quicker read times in Maya, we're compressing this as DWAB. So by default, it would be set to zip, and we're going to change it to DWAB. So this is visually lossless compression, where you can't really tell the difference between the images, but the file size that it gives you is much, much smaller, something akin to JPEGs. So we write this out, and that is our image plane that we take into Maya. So just to recap on that, it's undistorted, and it's at this format, 2080 by 1100, whatever is the result of this undistortion network here.